Hi, in this video we are going to solve problems by using Gauss Seidal method. So basically it's an iterative method, so if we do more and more iterations the accuracy will be more, and we are going to solve the linear algebraic equations which is diagonally dominant. What do you mean by diagonally dominant? Consider the set of equations a11x1 plus a12x2 plus a13x3 is equal to b1. Say if this is the first equation. So if you see here, the coefficient of x1 is a11 and this a11 modulus value of it will be greater than modulus of a12 plus a13. So for example, if you are having a negative sign over here, say minus 3, since we are going to take the modulus value, it's going to be plus 3. So consider these set of equations. Already we have seen this equation. Now look at the second equation. a21x1 plus a22x2 plus a23x3 is equal to b2. And if you see here, this coefficient, that is a22, in this equation, this should be diagonally dominant. So modulus of a22 should be greater than modulus of a21 plus a23. So again note this modulus value. So it means only we are going to take the positive values. And similarly, if you see the last equation, see here a33. So this should be the dominant value. So if you see here, modulus of a33 should be greater than the first term a31 plus a32. This is what I have written. So we are going to take x1 from this first equation, x2 from the second equation, and x3 from the third equation. So given a set of equation, we have to rearrange in such a way that in the equation 1, coefficient of x1 should be diagonally dominant, equation 2 coefficient of x2 should be diagonally dominant, and in equation 3 coefficient of x3 should be diagonally dominant. Let's see an example. Now consider this example. See these equations, x plus y plus 54 is equal to 110. If you see here, what is the highest coefficient? That is 54. It means this should be the third equation. So we are going to rearrange this. So and if you see here 27, this is the dominant one. And if you just check, modulus of 27 is greater than modulus of 6 plus modulus of minus 1. If you see the coefficient, this is minus 1, right? So so this is the dominant one in this equation. So this should be equation 1. And if you see here, y is dominant in this equation, y coefficient. So this should be equation 2 and this should be equation 3. So I'm just going to rearrange and take the values. So 27x plus 6y minus z is equal to 85. So I'm going to derive x from this equation. So 27x is equal to 85 minus 6y plus z. Therefore x is equal to 85 minus 6y plus z into or by 1 by 27. So we have taken x from this equation. Similarly, oh my god, let it be. Similarly, I am going to take y from this equation, that is equation 2, and z from equation 3. Try by yourself. So we got x from the first equation. Now we are going to derive y from the second equation. Let me take a different color. Yeah, so y is equal to, and what is the diagonally dominant value? 15. So 1 by 15 into, just refer that equation, 72 minus 6x minus 2z. And similarly, we'll take z from the third equation, that is 1 by 54 into 110 minus x minus y. And already we got x, and I will write it somewhere here. So x is equal to, in the previous slide we got x as 1 by 27 into 85 minus 6y plus z. So We got x from equation 1 and we got y from equation 2 and we got z from equation 3. So we are all set now, and as I told you, we are just going to repeat. So listen carefully for the first iteration, and it's just going to be the repetition of that. So what we are going to do for the first iteration means we are going to guess, and we are going to start with trial solution. So sometimes they will give the trial solution in the question itself. If they don't give, then as simple as that, take x value, y value and z value as 0. So to mention that this is your first iteration, just mark 1 like this. So already we have x value, that is 1 by 27 into 85 minus 6 into, for the first trial, what is the y value? 0 plus 0. So automatically, if you just calculate in your calculator, please calculate up to 5 decimal and truncate the 5th decimal. For example, after 5, if you have got some 4 or something, you can leave this as it is. So if it is a higher value, just increase 1. If it is some, say 7, you have to increase 5 to 6. So please truncate the digits properly. And y first iteration. Now 1 by 15 into y values here, that is 72 minus 6x. 72 minus 6 into, for x you are not going to use 0. What is the new x value I've got? 3.14815. So we are just going with the trend. So 3.14815, and so far no z with you, correct? So minus 2z. So z value is 0, minus 2 into 0. So if you simplify this, you will be getting 3. Check your calculator, 54074. Okay, so finally we have to do z. Okay, what is that? 1 by 54 into 110 minus, what is your latest x? Here it is, your latest x, 3.14815 minus y. What is your latest y value? Forget about the old y. So we are having 3.54 something. This is old. We don't want that. This is also old. So we got this new x and we got this new y, and we are going to use this 3.54074. That's it. So calculate this in calculator and you'll be getting 1.91317. So you are done with the first iteration. Now when you solve the second iteration, you will be using the same set of formulas, equation 1, 2 and 3. But instead of using the old value, what are the new x value? Here we got x, we got y and we got z. We are going to use this in the second iteration. So we are ready for second iteration. Remember, what are those values you got? You got x as 3.14815 from the previous slide, y as 3.54074 and z as 1.91317. From these are the first iteration value. We are going to use this for the second iteration, and since it is second iteration, I'm going to write x power 2. So 1 by 27, formula remains the same. Refer the previous slide. 85 minus 6 times x. So what is your x value? 3.14815. Here it is. Okay. So minus 6x plus y. Plus z. 1.91317. So 85 minus 6x plus z. So we have used these values, and the value you got is 2.43. This is 3. And then 43218. Sorry for this. Okay. And similarly y2. y2 is 1 by 15 into 72 minus 6 into x, right? So 72 minus 6x. Already this is old x and this is new x. So we'll be using new and we don't want old one. So 6x. So what I'll write? 2.43218. This new value. and minus 2z, minus 2 into z values here, 1 point, this value 1.91317. So hope you'll use the board mouse rule. So first we have to do the things within the bracket and then finally multiply by 1 by 15 with that answer, and you will get 3.57204. So if you notice, the difference between the corresponding x and y values will become lesser. So 3.14, from there it has dropped down to 2.4. 3.542, slightly it has come up to 3.57. It means your answers are correct. And finally you have to find Z2. So that is 1 by 54 into 110 minus x. So what is your new x? Here it is 2.43218, and then minus y. What is your new y value? Here your new y value. I don't want old one now since I got the new one. So 3.57204. So this is your second iteration and your values 1.92585. So we are done with 2 iterations. So already we are done with 2 iterations and you're going for the third iteration. I think you can try it on your own. In the third iteration you will get x value as 2.42569 and y value as 3.57294 and z value as 1.92595. So when you go for the fourth iteration, you will get x value as 2.42549 and y value as 3.57301 and z value as 1.92595. So I'm going to stop with this iteration because at least 3 decimals, if you see here, this is same. So we are done. 3.573, this also 3.573. So this is closer, we can stop it. And this one, if you check here, 2.425, 3 decimals, I'm just checking, 2.425, actually this will become 6 if I truncate, but this is almost close, so I'm stopping with this. Okay, so how to check your answer is right or wrong? Take any one equation, say your first equation, say x plus y plus 54z is equal to 110. You're just going to substitute these values, 2.42549, this is your x value, and this is your y value, 3.57301 plus 54 into your z value, 1.92595. If you substitute these values, just check what you are getting. Yes, so you are getting 109.998, which is closer to 110. So it means your answers are an approximate solution for this diagonally dominant equations. So you know that your answer is correct. So if we do more and more iterations, we will be going closer to the real root. Thank you.